Hi, this is an Excel tutorial for Eco 220 for the weeks of February 3rd to 7th. The week of February 3rd to 7th. Anyway, I've copied in the exercises from the Word document simply to make it easy to read. The first question it's going to ask basically to calculate the probability given an x, and then later on to calculate the x given a probability. So for the first part of the first question, it asks us what is the probability that x will be less than 1.65. So in this case, we're going to use the function normal distribution. To do this, we're going to type equal to start it off, and then we're going to type norm.dist, basically short form for normal distribution. Then we're going to type open bracket. When we do this, we can see exactly what it wants. It wants an x value, then a mean, then a standard deviation, and then it wants to know if it's cumulative or not. So for the x value, we're going to type 1.65. For the mean, we're going to type 0. The standard deviation, we're going to type 1. And then we do want it to be cumulative, so type true. True. There we go. That was difficult. Press enter, and there you have it, the probability that x is less than 1.65. In this case, it's about 95%. Moving on to the next one, now we want to know if x is greater than 1.65. The normal distribution function, you can't actually put a sign in for the x, so you can't tell if it wants it greater or less than. It automatically assumes that you want everything beneath 1.65 in a normal distribution. So in this case, how we're going to find the probability is we're going to use the fact that we know that there's a 100% chance that something will happen, which makes sense. So we're going to type equal 1, the 100% chance that something will happen, and then take away the probability of stuff we don't want happening. So in this case, it'd be the fact that x is less than 1.65. And that will leave us with all the probabilities that x is greater than 1.65. So that's about 5%. Moving on, now it wants to know the probability of x when it's between 1.65 and negative 1.65. So in this case, we're going to start it off with, once again, an equal sign. And we already know the probability that x is less than 1.65. So we're going to just take that from above, and then we're going to take away, oopsies, and then we're going to take away the probability that x is less than negative 1.65, because we don't want that. So once again, you're just going to type norm.dist, open bracket, and now the x is now negative 1.65. The mean is 0. Oopsie, 0. The standard deviation is 1, and it's still cumulative. Cumulative. Oh my god, this is difficult. There we go. Enter. So now we know the probability that x is between 1.65 and negative 1.65 is about 9%. So for the next part of the question, I've actually changed it slightly from the exercise. You see, in the exercise, they asked the question using like a larger x and a smaller x, but it's really, really hard to kind of try to verbalize that. So I've changed what we're looking for, our target, to be y. And so this y is some value where when x is less than y, it has a 90% chance of occurring. So to find this, we're going to type equal, and then we're going to use the function normal inverse, which in Excel is shortened to norm.inv. Now it's going to ask us the probability of the x occurring. So we want it to occur 90% of the time. We still want the mean to be 0 and the standard deviation to be 1. When we press enter, it gives us the y value. In other words, this means that when x is less than 1.28, it will have a probability of 90%. Alright, moving on to the next question. Now it wants to know y, given that when x is greater than y, it has a 90% chance of occurring. When we're looking for x greater than y, we're going to actually have to use the inverse of the probability that's given. So in this case, we're going to type norm.inv. And I know this is confusing. It's really hard to verbalize. I've been trying for like 5 minutes to try to figure out a way to easily verbalize this. So if you have any more questions, you can just feel free to leave a comment and I'll answer them. But, or, ask me in person. But in this case, because we want the inverse of the probability that we're targeting, because we want x greater than y, we're going to do 1 minus 0.9. And then we're going to take the same mean, same standard deviation, and that'll give us the answer. And which, it makes sense. Right, so for this next question, what they want is to find the value of y such that when x is between y and negative y, it has a 95% chance of occurring. So to do this, we're going to have to use a bit of use our understanding of the normal table and the normal distribution. We know that when x is between y and negative y, it's going to have a 9% chance of occurring. So everything outside of that range will have a 10% chance of occurring. And because the normal distribution is symmetrical, the values that are above y will have a 5% chance of occurring, and the values below negative y will have a 5% chance of occurring as well. Because the remaining 10% will be distributed evenly on either side of the range. Knowing this, we're going to use the function, once again, norm.inv. And now when asked for the probability, we're actually going to use the probability of 0.05. Because we want everything beneath the 5% chance of occurrence. The mean is 0 and the standard deviation is 1. There we go. So that's a value. So in other words, when y is negative 1.644, and what we have to remember in this case is that because y is, both positive and negative, this number could also be positive. So we're going to take this value here. There we go. So when y is either 1.644 or negative 1.644, or I guess 45 in this case, you're rounding, the x value will have a probability of 9% chance of occurring, because it won't have the 5% chance on either side of the range of occurring. Once again, if there are any questions, feel free to comment. Feel free to leave a comment, I'll get back to you. Right, moving on to question 2. Right, so question 2 is very similar to question 1, but instead of using a normal distribution, now we're going to be using a t-distribution, which is very similar, looks very similar to a normal distribution, except for the fact that they'll have fatter tails. Right, so the first question I want to know is, so the probability that t is less than negative 2 in a t-distribution with a degree of freedom of 15. So for this case, we're going to use the function t.dist. Pretty logical, makes sense. It's going to ask us for the value of x, in this case it's negative 2. It's going to ask us for the degrees of freedom, which is 15. And then once again, it's going to ask us cumulative. In this case, we still want that to be true. Right, so for the next question, it once again has flipped the sign on us. So now it's asking for the probability such that t is greater than negative 2, when t is greater than negative 2. In this case, once again, we're going to use the inverse. So we're going to do equals 1 minus the probability of what we don't want. Therefore, that means that there's a 96% chance that the 96% chance of occurrence when t is greater than negative 2, with 15 degrees of freedom. Right. Next, now it wants to know the probability that for when t is between 2 and negative 2. In this case, we're going to be using, once again, the same thing we did with the normal distribution. We're going to take the value for when t is less than 2. And then we're going to subtract when t is less than negative 2. Remember to make sure the degrees of freedom in each case are always 15. And there we go. And in the next part, much like keeping the style with the first question, it's going to give us the probability and it's going to want us to find the value of y. Once again, I switch y from small t because it's really hard to verbalize. So in this case, to find the value of y, we're going to use, you get logically the inverse of t. So once again, it's going to ask us the probability, so 0.9, and degrees of freedom, 15. There we go. So when t is less than 1.34, it has a probability of 9. It doesn't actually ask us how to flip it around, so when t is greater than y, I'm going to put that here anyway, because I think it's worth noting once again, just for, completion's sake, just to be thorough. So in this case, once again, we're going to need the inverse of the probability, because it only ever gives us the left-hand side, or the left side probability. So if we want to find something when it's greater than y, we're going to have to take the inverse of the probability that we want. Oopsies. Sorry. So in this case, we want not 0.9, so 0.1. 15 degrees of freedom. There we go. This is actually an equal sign. There we go. There we go. And once again, it's just the negative of what it originally was here. This question now asks us for y now in a range, so that the probability of t is 90 when it's between y and negative y. In this case, we can actually use a similar method that we did with the normal distribution. So we take t inverse, and then because we know it's 0.5, and the degrees of 15. And then once again, since it's y could be negative or positive, we can just go like that, flip it around. There we go. So now we have the value of y. So if y is either 1.75 or negative 1.75, when t is greater than, is in that range, you have a probability of 90. Right, so this part of the video, I'm actually going to do further explanation on like why we have to like flip it around. So we have to do like 1 minus 90 all the time, because I feel like I did a really poor explanation in the beginning. So basically what normal distribution does is it gives you the left-hand side of the probability. So it works great for when you're finding x is less than like 1.65, but since it only gives you the left-hand side, to get when x is greater than 1.65, you have to flip it around, hence the 1 minus 1.65, or the inverse of it. Similarly, when we're looking for the probability, like we're looking for the y value given the probability, the inverse only ever tells you the left-hand side. So when we're looking for when x is greater than y, we have to flip that around. And one last thing to add on. One more thing to add about the t-distribution is that they actually give you the option of taking two-tail tests instead of just a one-tail test that always is on the left-hand side probability. Left-sided probability, sorry. So in the for example, in this part where it asks you to find the probability given that t is between 2 and negative 2, you can actually use a different function called t.dist.2t. So now it will basically find the probability on the ends of the two tails when you give them a range. So the range you're given is a 2. Conveniently, it's negative 2 and 2, so that's why you can just use this. And then 15 degrees of freedom. In this case, now it's giving you the probability on the ends of either two tails. But we don't want that. We want the range in between them. So we're going to do 1 minus. There we go, giving you the same number. Remember though, the method I showed here originally, this you can use for any range. Like, you get to set the first range, the upper bound, and the lower bound. In the case of this one, you only get to use, like, it only assumes that it's perfectly symmetrical on either side. Therefore, it works in this scenario because you had 2 and negative 2. But for example, if you did 2 and negative 3, you would have to use the original method I just showed. A similar thing can be done for the student distribution inverse. So once again, we're looking for a range, and now we're looking for y, so we're going to be using the inverse. T inverse. And then once again, we're going to type 2t for two-tailed. And in this case, the probability is 90. Once again, we're looking for the outer bounds. Like the two-tailed test will give you the outside bounds of it, but we want the inside bound, so we're going to want 1 minus 0.9, which in case is 0.10. And there we go. That gives you the same values here.